Welcome everyone. So the last unit we learned about the limitation of the intrinsic semiconductor. We found out that intrinsic semiconductor is a poor conductor. So in order to build any meaningful electronics device, we need to increase the conductivity, and we found out that in order to increase the conductivity, either we have to increase the numbers of electrons or increase the numbers of holes. So that can be done by introducing some defect, which we learned it as doping. So either we dope impurity, for example phosphorus, to get higher numbers of electron, or boron to get higher numbers of holes. So this way there are two types of materials: N type, where numbers of electrons are more than the numbers of holes, and P type, where numbers of holes are more than the electrons. So in N type material, electrons is called majority carriers and hole is called minority carriers, and P type material, hole is called majority carrier and electron is called minority carrier. Okay, so this lecture, since we have got the idea of different types of material, N type material and P type materials, so this lecture we are going to learn about charge transport mechanism and the p-n junction diode construction, operation principle of diode at open circuit, a current component of diode at open circuit, and if time permits, we are going to learn about biasing, forward bias and reverse biased. So first of all, what is a charge transport mechanism in semiconductor? Now, when we are going to build any electronics device, we expect current will be flowing through the device, and we already learned that current through the current in the semiconductor is due to the flow of electrons and holes. So there are two mechanisms by which electrons and holes can move through the semiconductor. They are called one drift and the other one is diffusion. So these are the two mechanisms by which electrons and holes can move through the semiconductor. And we know that movement of carriers, either electron and hole, give rise to a flow of current. So there are two associated current. One is drift current, another is diffusion current. At first, we are going to discuss about the drift. So drift is the movement of carrier, which is electron and hole, caused by the electric field. So for example, let's say we take a p-type material. Inside the p-type material there is a hole, so which is indicated by this circle, and let's say the hole has a charge, which is charge q, and there is an electric field directed from right to left, which is E. So under the influence of this electric field, the hole, being a positive charge, it will be experiencing some force, and we can determine the force by using this equation: F is equal to QE. So since hole is positive charge, the direction of the force is in the same direction as the electric field. So however, since we call the hole as free, that means hole has the ability to move. So under the influence of this electric field, hole will be moving. The hole will be moving with a average velocity, which we call it drift velocity, in the same direction as the electric field. So we can say the hole has been drifted under the influence of this electric field. And since hole is moving, so there is a current associated with that with the drift of hole. So direction of the current is in the same direction as the hole. We call it hole drift current. So we do the same thing for electrons. So let's say we take an n-type material, and there is an electron inside this material which is free, and the charge of the electron is minus q. Again, the electric field is oriented from right to left. So under the influence of this electric field, the electron will be experiencing some force, and the force is F is equal to minus QE. So that means the force which is acting on the electron is opposite to the direction of this electric field. So again, since the electron is free to move within the semiconductor, we expect the under the influence of this electric field, hole will be moving with an average drift velocity opposite to the direction of the electric field. Since we have a movement of electrons, we have got a current, and this current we call it drift current. And again, since we know the direction of the current is always opposite to the direction of the movement of the electrons, so in that case current direction will be same direction as the electric field. So this type of movement by carrier under the influence of this electric field and the associated current for this is called drift current. Okay. However, there is another types of motion that can take place inside the semiconductor, and there is a current associated with this motion or with this transport. This is called diffusion. The diffusion process is the movement of carrier caused by the variation in concentration. Okay, so let me explain this with this example. Let's say we have a water jar, the jar which is filled with clean water, and then we put some drop of ink inside that. So you would notice the moment the drop of ink is poured, so this region will become blue, but rest of the water will become still clear. But if you allow some time, you will notice the ink particle will be distributed all over the region until the concentration of ink is uniform all over the places. So what exactly happens there is that particle moves from the high concentration area to the area of low concentration. For how long? As long as the concentration throughout the area is not uniform. So this process is diffusion. So diffusion takes place due to the variation in concentration. So that means we have a high concentration of ink here, and rest of the area where is low concentration of ink. So there is a variation. Due to this variation, ink particle moves from high concentration area to low concentration area. The same argument can be applicable to semiconductor as well. So let's say we have a p-type semiconductor. At one corner, somehow we managed to inject huge amount of holes. So clearly you can see at the top left corner, the concentration of hole is very high, but rest of the p-type material concentration of hole is very low. So that means we have a variation in concentration. So since there is a variation in concentration, and according to the rule of diffusion, particle will move from high concentration area to the low concentration area. For how long? As long as the concentration isn't uniform. So at steady state, we are going to find the concentration of hole all over the p-type material is uniform. Same concentration will be maintained. So, and since there is a movement of charge, the movement of hole, which means there is a movement of charge. Since there is a movement of charge, so there is a current, and this current is diffusion current. So current due to the diffusion of carrier is diffusion current.